Hello, so this is going to be, again, a really quick video on using partial fractions with binomial expansion. Questions tend to be structured something like this, where the part A will ask you to express the algebraic fraction as partial fractions. We then use it to show a cubic, in this example, approximation of that original algebraic fraction. So we would take each algebraic fraction, rewrite it as power, and then use binomial, collecting together our like terms all the way up to an x cubed term. And then part C is state the range of values for which the expansion is valid. So part A, the partial fractions, I've just done for you because hopefully we know how to do the partial fractions. And then we take each fraction and rewrite it as a negative power. So 3 over 1 plus x becomes 3 lots of 1 minus x to the power of minus 1. And then we're subtracting 2 lots of 2 minus x to the power of minus 1. Now the first thing we need to deal with is this 2. We need it to be a 1, so we factorize the 2 out. So the first bracket doesn't change. But then if we factorize out the 2 and raise it to the power of negative 1, that gives us a half. Multiplied by the 2 that's already there means that the 2 actually cancels out with the half, leaving us with just 1 minus a half x to the power of minus 1. And then we do the expansion for each of these brackets. So expanding 1 minus x to the power of minus 1 up to the cube, the x cubed term, we have 3 lots of 1 plus, and then we've got the minus 1 from the choose expression multiplied by minus x. Then we've got plus minus 1 times minus 2 over 2 factorial multiplied by minus x squared. And then plus minus 1 times minus 2 times minus 3 over 3 factorial minus x cubed. So that's the first bracket, the first binomial expansion. The second one we're then going to subtract 1 minus a half x to the power of minus 1. So we've got 1 plus, again it would be minus 1 multiplied by minus a half x this time, plus minus 1 times minus 2 over 2 factorial multiplied by minus a half x squared, plus minus 1 times minus 2 times minus 3 over 3 factorial, all multiplied by minus a half x all cubed. We then work out each term and then start to collect together the like terms. So we get 1 minus 1 times minus x is plus x. Then we get the choose function would just be, it would still be 1. So plus, and then minus x squared is positive x. So it would just be plus x squared. And again, I'm just checking back against my solution just to make sure I've got this right. Damn it. This is a plus. Oh, all these silly mistakes. Okay, so this is just x in all of these brackets. Not a huge mistake. So this is actually minus x because it's minus 1 times x. Okay, and then plus x squared, minus 1 times minus 2 times minus 3 over 3 factorial is minus 1 because that's minus 6 over 6 multiplied by x cubed, so minus x cubed. Again, let me just check that against my solution. Yeah, okay, that's correct. And then we're gonna subtract and then simplify this expression. So it's 1 plus a half x. That would be plus a quarter x squared, and then plus, no, minus, no, that would be minus 1. Like when I'm saying this would be minus 1, that's minus 6 divided by 6 is minus 1 times by minus an eighth. So it would end up being positive 1 over 8 x cubed. Yeah, that's the solution that I had before. Expand out the brackets, so deal with that 3 at the beginning, expand that in and expand the negative in as well, and then collect together your like terms. So you have 3 minus 3x plus 3x squared minus 3x cubed minus 1 minus a half x minus a quarter x squared minus an eighth x cubed. Then 3 minus 1 gives us 2. Minus 3x minus a half x gives us minus 7 over 2x. 3x squared minus a quarter x squared is 11 over 4x squared. Minus 3x cubed minus an eighth x cubed would be minus 25 over 8x cubed. Oh, of course it is, because because I tried to show it's here. Yeah. Okay, so there we go. We've shown that the cubic approximation of 4 minus 5x over 1 plus x multiplied by 2 minus x is 2 minus 7 over 2x plus 11 over 4x squared minus 25 over 8x cubed. We've shown that by splitting it up into partial fractions and then doing a binomial expansion of each of those partial fractions. Okay, we need to do part C. I'm going to do it up here. Oh, change back to the pen. State the range of values of x for which the expansion is valid. So to do that, we need to look at both of the partial fractions and when they would be valid. So for 3 over 1 plus x, or 1 plus x to the power of minus 1, modulus x has to be less than 1. For 2 over 2 minus x, when we take out the factor of 2, we get 1 minus a half x to the power of minus 1, which means that modulus of a half x has to be less than 1, meaning x is less than 2. Because the expansion has to be valid for both of the partial fractions, we need to choose, I'm not sure what the right word is here, but I want to say the strictest. Like, we need to choose the smallest inequality. It has to be true for both. So modulus x is less than 1 is true for both of the partial fractions, whereas modulus x is less than 2 doesn't work for the first fraction, because on that it has to be less than 1. So if we had a value of, say, 1.75, it wouldn't work for the first binomial expansion. I hope that makes sense. So we're basically combining these two inequalities, but when we combine them, we actually end up with modulus x is just less than 1, because that works for both of the works for both of the expansions, both of the partial fractions. I'm not sure I've explained that all too well. I'm hoping I'm just overcomplicating and it's a pretty easy concept to grasp. You have two inequalities. You have two ranges where the expressions are valid, and you need to combine those inequalities together. I mean, it's a GCSE skill, is combining inequalities, so hopefully that makes sense. And that's it. That is binomial expansion done. Over the holiday, wrap up the last 2 exercises and the chapter review. And yeah, maybe work through at least one P3 exam paper would be my advice. I'm going to try and drop some into the sixth form centre tomorrow. I have asked for them to be printed. I just need to double check that they have been. When I checked yesterday, they weren't ready. So yeah, I'll try and pop some papers into sixth form tomorrow so that you have another couple to do over the break. Obviously, you've got one that I gave you early in the week. Yeah, I think that's everything. When we come back after the holiday, we'll go back to chapter 3 and have a look at parametric equations. Yeah. Okay, right. If I don't see you, have a lovely half-term holiday. Keep on top of your P3 is my main piece of advice. Keep going back over it. Do a paper, pick out some topics, go back over those topics, and just keep repeating that cycle between now and spring break whilst we're still kind of wrapping up P4. By the time we come back from spring break, we'll have finished everything and we'll be more focused on revision, but for both. So really keeping on top of your P3 now is important. Okay, anyway, this was a video on partial fractions that's now turning into a lecture about revision. So I'll stop now. Enjoy your break if I don't see you, and thanks for watching the video if you did.